Welcome back. For this video, we are going to take a look at some derivations. We're going to derive two sets of problems, or the x and y part for two sets of problems. So for the top half of this page, we're looking at objects pulled at an angle. So this would be like if you were pulling a lawnmower or something like that. Or it could be a pushing problem where you're pushing a shopping cart or a lawnmower or something. And for that, we derived f of x equals f cosine theta and f of y equals f sine theta. So I'm going to show you where those came from. And then on the bottom half of the page, we have an inclined plane, and we have to find the perpendicular and parallel forces. So f perpendicular and f parallel is inside that box there. And we have mag cosine theta and mag sine theta. So I'm going to derive that as well. So if you want to skip ahead for that derivation, it'll be at the bottom. And so this is not required to know how to do it, but I know some people just generally want to know where these come from. And so I want to show that for you. So let's start with the first one. And what we first need to know is about sine and cosine. So sine is equal to opposite over hypotenuse, and cosine is equal to adjacent over hypotenuse. And these are just their definitions. This is what they're defined as. And what we're talking about is when you have a triangle and you have, can we erase that? Yes, okay. So this is a right, oh my gosh. Okay, let's try this again. So we got a triangle. This is a right angle. This is our angle theta that we're pulling it at. So we're pulling it with this force kind of going up this way. Okay. So we want to break it up into this x part and this y part. So this force that's going up at our angle, this F, has part of it is going horizontally and part of it is going vertically. So we want to break it up and find out how much is going in the x direction and how much is going in the y direction. And so like even if this F is 10, it could be 10 at that angle or it could be 10 at this angle. And if it's at this angle, it's going to have a much bigger x part and a much bigger y part, right? So the angle here makes a difference. So those lines, those F lines, might be the same length, but their angle is going to affect how much is in the x part and how much is in the y part. So we're going to use these trig functions and of sine and cosine, and the adjacent angle is the one next to, so the adjacent side is the side next to the angle. So that would be our x. So this is adjacent. And opposite is opposite the angle. So if we have our angle is theta, the opposite side would be over here. This is the opposite of our angle. Okay, so if I want to rewrite it, if I have my f and my fy, oh, and the hypotenuse is over here. This is my hypotenuse. It's my f. So instead of writing it as hypotenuse, opposite, and adjacent, I'm going to write it as f, fx, and fy, because we're talking about forces. So I would have sine of theta equals the opposite side, which is my fy, and the hypotenuse is my f. Okay, so what I can do is I can put this over 1 and cross multiply, and I would get fy equals f sine theta. That's one of them. And for the other one, I'm going to use cosine. So cosine is equal to the adjacent over the hypotenuse, which is what I wrote up here. So the adjacent is my x, and the hypotenuse is my f. So I'm going to cross multiply again. And I would get my two identities. So if you want to find this number, the f of y, you would use f times the sine of the angle. And if you're trying to find this number, that's f of x, you would use f cosine of the angle. All right, let's take a look at the second type of problem, which is an inclined plane. Okay, for an inclined plane, we still have a right angle over here. Gravity is going to pull down. So let's change colors for that. So gravity pulls down. Let's put it over here. This is my force of gravity. The normal is straight up, but it's straight up from the surface. So it's not going straight up, it's kind of going at an angle here. This is my normal. Okay, and the box, it's sliding down the ramp. So there's different types of these problems. Some of these have friction, some of them don't have friction. Some of them, the box is even sliding up. But for all of these, we're looking at perpendicular to the surface, that's our normal, and parallel to our surface. So if the box is going this way, we want to know this parallel piece, parallel to the surface, and we also want to know this perpendicular piece, which is equal to our normal. That's the one that's going straight up from the surface. So if I take this vector and this vector and I move them, I could rewrite them over here. This is like my normal, and this is like my perpendicular. So this is the same as that, and this is the same as the other one. I just kind of moved them. I moved them from up top down here and connected them to the gravity. So now I want to find what those values are. And I'm going to use trig again. So because my ramp is at a degree theta, I can do some fancy geometry and get that this angle is also theta. And then once I have that, all the rest falls into place. So I can use my same trig identities. So cosine is equal to adjacent over hypotenuse. Okay, so cosine, my adjacent next to the angle, that's the perpendicular side. And the hypotenuse is the force of gravity. And actually, I should write it as cosine theta. Let me try that one more time. Cosine theta. Okay, so I'm going to do the same thing. I'm going to cross multiply. I'm going to get perpendicular is equal to the force of gravity. That's my hypotenuse, cosine theta. And I'm going to take one more step and rewrite force of gravity as mass times acceleration of gravity, which is 9.81. And I can do the same thing with sine. Sine is opposite over hypotenuse by definition. So the sine of the angle, the opposite side from my angle is the parallel. And my hypotenuse is the force of gravity. I'm going to cross multiply again. And I get this is equal to the force of gravity, sine theta. And once again, that's equal to mass times the acceleration of gravity times sine theta. And those are our two identities. So you don't need to know the process, how we got those, but you definitely need to have these memorized or be able to find them. I was trying to get my highlighter on. So you definitely need to know that one, and then these two. All right, definitely know those four. Like I said, you don't need to know how we got those. You don't have to do what I just did, but definitely have those memorized because you're going to need those for any type of problem like these two. So if you're pulling at an angle or on an inclined plane. All right, there you have it. Thank you very much. If you have any questions, please let me know.